As of now, we've been training our models with a fixed learning rate. So for as we increase the number of epochs, our learning rate remains constant, and then once our model converges, we stop training. It's important to note that this isn't the most optimal strategy for extracting all the jewels from our model, or from getting the best out of our model. And this is because sometimes during training, we may get to, say, this point here. And then because our learning rate is relatively large, this model will find it hard getting to this minimum point here, talk less of this other minimum point. But if we could reduce the learning rate as we go on with the training, once it gets to this point, it will find it easy getting to the closest minimum point, and which will make the model even perform better. But you may be asking why we don't just start with a very low learning rate so that we are sure of getting to the lowest possible minimum point. The problem with this is that when you start with a very low learning rate, the model will take too much time to train. So we start with a high learning rate, or with a relatively high learning rate, so the model initially converges as quickly as possible. Then as time goes on, when the model's performance starts to stagnate, we start to reduce the learning rate so that we could achieve better performances. A typical learning rate decay scheme looks like this. You see, for the first iterations, we started with this learning rate of 0.001, and then after a certain number of epochs, we reduce the value, and then we start reducing this value constantly. We get to this point, reduce, and then we stop reducing once we get to a certain learning rate which we fix. Because obviously at a certain learning rate or below a certain learning rate, our model must have reached a point where it can't converge further.